Fire alarm systems are designed to alert us to an emergency so that we can take action to protect ourselves, staff, and the general public. Fire alarms are found in offices, factories, and public buildings. They are a part of our everyday routine, but are often overlooked until there's an emergency, at which point they might just save our lives. Whatever the method of detection is, if the alarm is triggered, sounders will operate to warn people in the building that there may be a fire and to evacuate. The fire alarm system may also incorporate a remote signal system, which could then alert the fire brigade via a central station. In this video, we will have a look at the structure and types of the fire alarm systems. The brain of the system is the fire alarm control panel. It is the central hub for all of the detector signals to be wired to, and provides a status indication to the users. The unit can also be set up to simulate an alarm for use in routine fire and evacuation drills, so all staff knows what action to take in the event of a real fire. At the core of a fire alarm system are the detection devices, from sophisticated intelligent smoke detectors to simple manually operated break glass units. There are a wide array of different types, but we can divide them into groups, including heat detectors, smoke detectors, carbon monoxide detectors, multi-sensor detectors, and manual call points. A heat detector can either work on a fixed temperature basis, where it will trigger an alarm if the temperature exceeds a preset value, or they can work on the rate of change in temperature. Commonly, heat detectors work in a similar way to an electrical fuse. The detectors contain a eutectic alloy, which is heat sensitive. When a certain temperature is reached, the alloy turns from a solid to a liquid, which in turn triggers the alarm. There are three basic types of smoke detectors, including ionization, light obscuring, and light scattering. An ionization smoke detector generally contains two chambers. The first is used as a reference to compensate for changes in ambient temperature, humidity, or pressure. The second chamber contains a radioactive source, usually alpha particle, which ionizes the air passing through the chamber where current flows between two electrodes. When smoke enters the chamber, the current flow decreases. The drop in current flow is used to initiate an alarm. The light scattering smoke detector operates on the Tyndall effect. A photocell and light source are separated from each other by a darkened chamber, such that the light source does not fall on the photocell. The passage of smoke into the chamber causes the light from the source to be scattered and fall on the photocell. The photocell output is being used to initiate an alarm. In the light obscuring smoke detector, smoke interferes with a light beam between a light source and photocell. The photocell measures the amount of light it receives. The variation in photocell output is being used to initiate an alarm. This type of detection can be used to protect large areas, with a light source and photocell positioned some distance apart. Carbon monoxide detectors are also known as CO fire detectors, and are electronic detectors used to indicate the outbreak of fire by sensing the level of carbon monoxide in the air. Carbon monoxide is a poisonous gas produced by combustion. In this instance, these detectors are not the same as carbon monoxide detectors used in the home for protecting residents against carbon monoxide produced by incomplete combustion in appliances such as gas fires or boilers. Carbon monoxide fire detectors use the same type of sensor as those in the home, but are more sensitive and respond.